Okay, so what I want to do is a quick demonstration of how to create the half sine and then how to look at it and manipulate it and control the gain of it so that ultimately we can implement a voltage feedback. So what I did is I created this little sample code. All right, so we're going to create a half sine array. We're going to read the array back. Okay, and we're going to use the serial plotter and the serial monitor to take a look at the data. All right. I'm using an Arduino Nano right now. It's just plugged into the serial port. Or you can use whatever you want, an Uno, Mega, whatever you want. This code will run, and you can demonstrate this. So we have four variables, right? The first variable is called increments, and it's an integer value set to 180, okay? And the second is an array that I've called half-sine array. And it contains increments, which means it has 180 elements in that array. Okay, and it's static; it's not going to change. Then we have a float called gain, and it's set to 1. Okay, and then we have another variable called half sine. Now, in setup, we're going to do a serial begin at 9600 baud, and we're going to go ahead and we're going to create the half sine array using the sine function. And the way we accomplish that is we make a for loop. And the for loop runs, I will increment up to less than the number of increments, which in our case is 180. So less than that is 179. So it's going to go from 0 to 179. So what we're going to do is we're going to take the sine of that increment value. We're going to multiply it by pi divided by the increments, and then we're going to multiply that by 255. And 255 happens to be, we're using an 8-bit counter for the PWM, so 255 is the top, okay? And we're then going to take, at that increment value, we're going to address the array at that increment value that it's at, and we're going to insert the value for the sine. And it's going to do that for all 180 values from 0 to 179. And that will store our array. Okay. Now we want to go ahead and read that array back. So the way we're going to do that, we're going to wait a second. Okay. And then we've got another for loop set up in the same way. It's going to increment from 0 to 179, okay, and that increment value will address this half sine array, so it will read out what's in the array at that I increment value. It will multiply it by the gain, which in our case now is 1, and then that's the value that will be put into the half sine variable, and then we will print that variable out. Okay, I'm going to go ahead and run this. Okay, and then when it's done running, I'm going to open up the serial plotter. So it's done uploading. Open up the serial plotter. Okay, and you can see that it plots 1/2 cycle. Okay, so it's going from 0, right, up to 255. And then back down, not quite to 0, because the next cycle will start at 0 again, right? So if I reset my Nano, I'm going to push the reset button, so it will create another cycle. You'll see that it continues. So you can see that you get from 0 to 0, right? And this is a gain of 1, so it's going to 255. Now, if I change the gain, let's say I change the gain to 0.8. So 0.8, okay, and I run this again, okay, and I leave the serial plotter open, okay, so when it's done, it'll just continue on, right? Now with a 0.8 gain, you can see that I've reduced the amplitude of the half sine. So this gain function now, since these values are driving my PWM, which is controlling the duty cycle, I can control the amplitude half bridge modulator at stage 2. Let's go ahead and just look at the, we'll look at it again. I'll hit the reset button, right? But I'll just go to the serial monitor now. So I hit the reset button, and now you can just see what it does. So these are the actual values. So 0, 4, 8, 13, 17, 22. So this is what's forming the sine wave as integers. And then back down 8, 4, right? You can see 8, 4. And then when it starts again, it'll start again 0 here.